Hello, this is Rick Powers from Western Technical College, doing a little strange thing about Newton's method, which is in calculus. And initially, when I thought about Newton's method, it just did not hold any magic for me. I was like, I don't care about this. What is it? But as it turned out, I started working with Desmos, and I was like, this is really pretty interesting. And so I said, well, I'll do a little video just to show you what it's like. All right, so Newton's method. What's involved here? It is using the derivative to find solutions, and we should say numerical solutions of complicated equations. So I'm going to have something like sine of x is equal to 1/4. And I want to be able to figure out what that is, but there's no algebra that it will tell me what this is. I can't put it in a Pythagorean theorem or something like that in order to find out what this number is. It's just a number, some kind of a decimal number, but I don't know what it is. And so then it's like, how can I find what that is? Well, certainly if I go to Wolfram alpha and I say, what's the arc sine of 1/4, the inverse sine, then it'll give me this number, and it'll go out to however many digits, and if I want more digits, it'll give me plenty of them. But how does it get that? And how can I figure out how to do things like this? What's the process of figuring out a number, which I can't use algebra for, and what can I do? And it turns out if I can use the derivative, it's a way for me to be able to find out what that thing is in a way that's pretty efficient and pretty effective and works pretty well. Although when we say, okay, how would I do this if I was going to use Desmos? Well, first of all, going back here to this, if I say that the sine of x is equal to 1/4, then I can actually rephrase that as being the sine of x minus 1/4 is equal to 0. And so I can have this thing on this side. This is going to be my function, f of x. And I want to know where the function f of x is equal to 0. So this will be a way for me to know when it crosses the x-axis, the y value is 0. And so I want to know what x value is going to make this work. So I'm looking at a solution. I'm looking for an x value that can go in here to make this work. So if I go here and I use f of x is equal to sine x minus 1/4, then that is my function right here. And so this is the graph. And I say, okay, where this number, I know from what I've seen, this thing here, I can get an approximation of what it is. And so then when I click on it, it turns out it's 0.253, which is consistent with what Wolfram alpha said. But I want to be able to get this to like 8 digits of accuracy. And if I start zooming in here and I say, well, I'll just zoom in. I'll just zoom in more and more and find out what it is. So it's about 0.25, and then I say, okay, 2.5, and I just zoom in because I can do that. 2.52 and 2.526, and then 2.526 to 2.5265, and then I keep zooming in here, and then all of a sudden Desmos stops telling me where I am. I'm 2.5268, 2.5269, and then it's like, well, you're on your own now. Okay. You're somewhere in between now. You can count the squares if you want to, but it's not actually going to tell me what that number is. And so I'm like, well, I'm here, and it's 2.5268, but I want to have it a lot more accurate than that. I just can't. I can't use Desmos to make that happen. So I go back out here and I say, okay, I want to know what this number is. Well, how can I do this? What can I use the derivative for? The derivative, remember, is going to be giving me a tangent line right there. And if we go to the textbook and we look at what it says for that, then what I'm looking at then here is, it looks like I closed that for some reason. Go to my e-book. Oh, it's not letting me. It closed it. Wow, that wasn't very nice. When I started making a video, I closed my book. So anyway, I'll tell you what's in the book. So what I have then here is I have a curved line. And if I have a curved line, then I say, well, what would I like to have? If I had a straight line, then I would be able to figure out where it crosses. It would be easier to work on a straight line than a curved line. So this is what I'm going to do. I'm going to use a straight line as an approximation here and see where that is and see if that'll give me something that's close to my solution. Okay, so I'm going to have an initial guess, and I'm going to show you how this works. Here's my initial guess. Here's my initial guess. This thing right here, 1.13. Now that's way far away, but just to illustrate how this works. Here's my initial guess. It's right here, and it comes up here, and then I figure the tangent line from there, and I find out that it hits down here at negative 0.404. Well, I'm far away from where I want to be. But then what I do is I take that number where I crossed, and I use this formula, which is right here, which has the function divided by its derivative. And the book goes through and shows you how this works and how you can actually make this happen so that you find out this next number. And then I use this number to guess the second time. And so I'm going to take this number then. I'm going to put that in here, and notice what happens. That I put this number in here, I find the derivative, and now I'm really very close to what that's supposed to be. Okay? And so when I click on this, it ends up to be 2593. Now, what you can see here is when you go through that process, 2953, it's getting me pretty close. And then now I'm really close. So I'm right here, and I'm going to pick this as my third time. And notice I'm just right almost on top of the thing right now. So after just 3 times of going through the process, I guessed that it was 1.1 something, which I knew was pretty far away. And it found this point. And then I used that as my guess down here and used my straight line to get me closer. And now my third time, wow, I'm just about right on top of the thing, as you can see right here. And so then if I do this a 4th time and a 5th time, I'm just getting really, really close every time. And by the time I get here to the 5th, if I compare the 4th one to the 5th one, then you can see I've got 2526802. So there's 1, 2, 3, 4, 5, 6, 7. 7 digits of accuracy, which Desmos could not get for me by just zooming in on the thing. But if I use this method, this Newton's method, then it's able to use approximate straight lines to really just narrow that in very closely so that I can have approximately this accuracy. Now, it's not just that, but I can do this for any kind of a function. So it works really well when I do something like that. So this is Newton's method. So you can see what it looks like. And then you can look through the book and see what they say about it too. All right, there you go.